Hello everyone, welcome back to the channel. This video is the continuation of the factors affecting the absorption rate. So, the dissolution and solubility rate we are going to discuss in detail. Remember how we said a drug must dissolve before it gets absorbed? Well, this part, solubility and dissolution, is often the rate determining step. Let's decode why it matters so much and how we classify drugs based on it. So what is dissolution? Dissolution, it is the process of a drug going into solution, that is solubilization of a substance in a given solvent. For example, like how sugar dissolves in tea. And dissolution rate plays a significant role as it's regarded as RDS, rate determining step in absorption process. So in absorption process, dissolution will be placed as rate determining step. For many drugs, like we'll discuss poorly water soluble drug and highly water soluble drugs. Like for poorly water soluble drugs like spironolactone and cruciferin, dissolution is the rate determining step in the absorption process. Where for highly water soluble drugs, dissolution will be rapid. Okay, example neomycin and creomycin sodium. Okay, for poorly water soluble drugs, dissolution will be RDS. For highly water soluble drugs, the dissolution will be rapid. Okay, then a drug needs minimum aqueous solubility more than 10 mg per ml for predictable absorption. If it is less than 1 mg per ml, absorption becomes erratic and unpredictable. Okay, then we have the MAD equation. Okay, the science behind it is this equation shows that how solubility is directly influence the absorption rate. Okay, absorption rate and solubility, we are getting the relationship between them. So MAD equals to Ka HGI VGI Tr, where Ka is the intrinsic absorption rate. Then we have SGI. SGI is solubility in GI. Then VGI is GI fluid volume. TR is drug residence time. This equation shows us how solubility directly influences absorption rate. Okay. Then we have the BCS classification. It means biopharmaceutical classification system. Okay. This system classifies drugs based on permeability and solubility. It is classified in 4 types. Okay, 4 classes we can say. So class 1 has the metoprolol and diltiazem. Their rate determining step is gastric emptying time. Okay, so gastric emptying time is the rate determining step. So their permeability, solubility won't be affecting. So they will be high. Then we have nifedipine and phenytoin. Their rate determining step will be dissolution. So what happens to the dissolution? Dissolution will be solubility will be low, whereas permeability is not getting affected, so it is high. Then we have insulin acyclovir. Insulin acyclovir rate determining step will be permeability. So permeability will be low, but solubility is not getting affected, so it is high. Then we have Taxol and HCT, hydrochlorothiazide. Their RDS will be very, so both of them will be low. You can remember this table. Like first, this table is all about the solubility and permeability. So headings will be remembered. Then we are dividing into classes, so class heading will be there. Then rate determining step and example we have to include. First of all, write all the classes. There are 4 classes we know, 1, 2, 3, 4 class. Then write solubility, permeability, RDS and example. Example you have to remember it, okay. After remembering the example, remember the rate determining steps. First one is gastric emptying time. It is not, it has no concern with the permeability and solubility. Okay, so you can remember gastric emptying time. There will, the rate determining step will be not solubility and not permeability. So what it will be, gastric emptying time. Then second will be the solubility. In solubility, dissolution will be rate determining step. Then third we have left with permeability. Then fourth, no options will be there, so varies. Then what is written here will be low here. Okay, gastric emptying time will be low here, but we are not including gastric emptying time, so others will be high. Dissolution is written here, so it will be low here, others will be high. Then permeability is written here, then it will be low here, other will be high. Then various means all will be affecting or not, we don't know, so low we have to put. Or other method will be, first of all on the bottom write high, then on in the, no, first of all on the top, sorry, top write high, then on the bottom write low, then alternatively write low high, high low. Okay, so next time you take a tablet, remember it's not just about what's inside, but how well it dissolves and travels through your body. Solubility and dissolution might seem boring, but they are the reason behind success or failure of a medicine. So if you found this video helpful, make sure you share it with your other friends, and if you are new to our channel, make sure you subscribe. We'll meet you in the next video. Till then, study hard. Thank you.